All right, so we're going to find the second derivative with respect to x of this equation. Now, this is an equation that describes a circle. And so then it's not going to be a function of x or, a function of y, on the entire domain. So it's going to be an equation that's, defined implicitly. So to differentiate it, we're going to need to apply implicit differentiation. So to do that, when we differentiate the x squared term, we just go about it like, you normally would. We go and use the power rule. We get 2x plus, and then when we differentiate the y squared term, you apply the same power rule that you would normally. So it'd be like plus 2y. But then here, you're going to multiply it by dy over dx. So you're going to multiply it by dy dx. And make that equal to the derivative of 25. And since that's a constant, it'll just be 0. Now we're going to solve for dy over dx. So let's bring it, keep it on the left and bring all the other terms to the right. And you essentially want to just understand that dy over dx, that even though it looks kind of weird, it can still be treated like it was like a regular variable. Think of it as like you're solving for t or something. So you can multiply, divide, factor it just like you could with normal variables. So what we're going to do is we're going to take away this 2x from both sides. So then we're going to have 2y times dy dx on the left. And that'll be equal to negative 2x. And then we're going to divide by this 2y. And then what we get is that dy over dx is equal to negative x over y. This will be our equation for dy dx. Now, we want to find the second derivative of y with respect to x. So we're going to take the derivative of this again. So we differentiate this by using the quotient rule here. So we have the top function over the bottom function. We can think of this like an f and that like a g. So let's maybe write it over here just in case you want to need a little refresher. So if we have something like the f over g, and you're going to differentiate this will be equal to the top derivative. So f prime times g minus f times g prime all over g squared. There's a review of the quotient rule. So the x, the negative x, think of it as like your f, and then the y as your g. So let's go ahead. Let's start going through it. Let me switch my marker here instead. All right, so the derivative of negative x would just be like a negative 1. So we'll have the second derivative of y with respect to x is equal to negative 1 times the bottom function, so times y, so negative 1y, minus f, so we'll leave the negative x there. And then we take the derivative of the bottom function, so times y. And since we're differentiating a y term, we're going to need to multiply this by dy dx. And this will be all over the bottom term squared. So this will be all over y squared. Now, what we need to do is we need to replace dy dx with the equation for dy dx because we have it here. And so then we can rewrite this as the second derivative of y with respect to x will be equal to negative y plus an x times a negative x over y. And this will be all over y squared. Now, from here, it's pretty much, a done deal. We just got to clean it up a little bit. So we'll have that. This will be equal to negative y minus an x squared over y. This is interfering. Let me kind of like make this a little bit smaller. Over y squared. So minus an x squared over y all over a y squared. And then, depending on how you want your final answer written, you can, make all of them have a denominator of y, combine the top, and then, use some math, some algebra skills to simplify it. And what we can do, let's multiply this by a y over a y. And then so we'll have, this will be equal to a negative y squared over a y. And then since this has a y in the denominator, this will be minus an x squared on top. And then this will be all over y squared. And then from here, let's go back over here. This will be equal to, let's just flip and use our fraction multiplication, multiplying by the reciprocal. So negative y squared minus x squared over y times, remember the bottom is like the same as y squared over 1. So times 1 over y squared. And so this will be negative y squared minus x squared all over y cubed. And then you'll probably see the answer written like this. From here, we can factor out a negative 1. So we can have to like a negative 1 times a y squared plus an x squared all over a y cubed. Now, if you go back to the original equation, you can see the x squared plus y squared is equal to 25. So we're just going to replace this with 25. So your final answer will then be equal to negative 25 all over y cubed. And there you go. There's a second derivative.